Hello everyone. In this video we'll be talking about the application of first order differential equations to chemical action. So let's take a look at the question to explain these concepts. Now the question says, under certain conditions, cane sugar is converted into dextrose at a rate which is proportional to the amount unconverted at any time. Now I said if out of 75 grams of sugar at T is equal to 0, that is initially 8 grams are converted during the first 30 minutes. Now we're required to find the amount converted in 1.5 hours. So the first thing we'll do is to generate the mathematical model for this problem. And to do that, we'll take a look at what the question is asking us. And we've been told that under certain conditions, cane sugar is converted into dextrose at a rate which is proportional to the amount that is unconverted at any time. So let's N naught be the amount of cane sugar or the initial amount of cane sugar. And let N be the amount of cane sugar that is converted into dextrose. So since we know the initial amount of cane sugar that is present and the amount that is converted, it means the amount that is unconverted, or say the unconverted amount of cane sugar. So the unconverted amount of cane sugar will be equal to N naught minus N. So we're making progress. So the rate at which cane sugar is converted is proportional to the amount that is unconverted. So I think we should have an idea of what the differential equation is going to look like. So the rate of conversion of cane sugar is dN dt, and is proportional to the amount that is unconverted at any time. Can I rewrite this as dN dt is equal to k multiplied by n naught minus n, and k is a constant. Can now solve this. dn dt now equals k multiplied by n naught minus k multiplied by n. We can simplify this to be dn dt plus kn is equal to k multiplied by n naught, and this is a first order linear differential equation. So we need to solve this using the method of solving first order differential equation that we have discussed before now. And check out the video on that to refresh your memory. So the integrating factor will be equal to e raised to the power of integral of k dt, and that's e raised to the power of kt. So the solution will be the integrating factor multiplied by n, that is n e raised to the power of kt, to be equal to the integral of an naught multiplied by e raised to the power of kt dt plus constant, say c. So we can then rewrite this on writing this. We have n e raised to the power of kt to be equal to k n naught integral of e raised to the power of kt dt plus c. So we have n e raised to the power of kt is equal to kn naught multiplied by e raised to the power of kt divided by k plus c. So n e raised to the power of kt is equal to n naught e raised to the power of kt plus c. And dividing through by e raised to the power of kt, we have n to be equal to n naught plus c e raised to the power of minus kt. So now we need to obtain the value of the constants c and k. We're told that when t is equal to 0, the amount of sugar present there is 75 grams. And we know that the amount of sugar converted at that point is 0 gram. So you can substitute these three into the equation above. Then we have 0 is equal to 75 plus c e raised to the power of 0. So this means 75 plus c is equal to 0, and c will be equal to minus 75. Therefore, n will be equal to n naught minus 75 e raised to the power of minus kt. So we still need to get the value of k. So let's proceed. To get the value of k, we have also been told that during the first 30 minutes, that is when t is equal to 30 minutes, 8 grams were converted. So this means the amount of sugar converted, which is N, is now 8, and our N naught, which is the initial amount present, is 75. So we know that N is equal to 75 minus 75 e raised to the power of minus kt. So 8 will be equal to 75 minus 75 e raised to the power of minus kt, or minus 67 will be equal to minus 75 e raised to the power minus kt, and on multiplying both sides by minus 1, we have that 67 will be equal to 75 e raised to the power of minus kt. So e raised to the power minus kt is equal to 67 divided by 75. And in this case, t is equal to 30 minutes. So we now have e raised to the power minus 30k will be equal to 67 divided by 75. So we can leave it this way rather than having to solve for the value of k. And we can put this back into the original equation. So we know that n is equal to 75 minus 75 e raised to the power of minus kt. If we want to write this back in this form, we know that n will be equal to 75 minus 75 e raised to the power minus 30k, then multiplied by t divided by 30. So n now becomes 75 minus 75 multiplied by 67 divided by 75 raised to power t divided by 30. So this gives the general form of the solution. Now we're asked to find the amount converted in 1.5 hours. In order to find this, we know that t is equal to 1.5 hours, and this is equal to 90 minutes. Therefore, to find the amount converted, we substitute t to be equal to 90 in the solution, in the equation. 67 over 75 raised to the power of 90 divided by 30. So we have n to be equal to 75 minus 75 multiplied by 67 over 75 raised to the power of 3. So this becomes 67 divided by 75. So we can simplify this to be n to be equal to 75 minus 67 raised to the power 3 divided by 75 squared. And this becomes 75 minus 300763 divided by 5625. So n now becomes 21.531 grams. So therefore, 21.531 grams of sugar is converted into dextrose in 1.5 hours. And with this, we've come to the end of this video. I hope after watching this video, you can now develop the mathematical model for questions on chemical action and also solve questions confidently. So thank you very much for watching this video and see you in the next video on vertical motion.